Hey, let's see if this works again. Should do. This works again. Yes, it does. Great. Okay, sounds good actually. Um, so it's been a while again. I think just because I'm struggling to get through all the other stuff I've got to get through. So I've got some time now. Uh, but the same problem will happen again because I'm also working on a game and it uh, I need to work on the game to learn Unreal Engine, but at the same time it's cutting into the time for learning what I need to learn to actually do this task. But that's good, that's fine. So anyway, that's where I've been. Um, let's see. I don't really remember what we were looking at before, to be absolutely honest. But I have been going to pubs and stuff, trying to figure out just why we can't know the position of an electron at some point in time. It, from what I've heard, it seems like the the more you know about the momentum of the electron, the less you know about its precise location. And that's a problem because if I want to know how something is if how an electron's charge is going to pull towards a proton, then I need to know where it is, because if there are two atoms, let's say, and one's pulling, from here and one's pulling from here, then I need to know that it's going to move in this kind of spin. I think that's my intuition. So I've been trying to investigate that. I don't quite understand the physics and maths behind it yet, and I think that's roughly what I'm trying to aim towards at this moment in time. I've got a keen interest in understanding that electron spin. You can see here, I think this might have been what I started to look at. So um, some educational HTML site there. Okay, looking at Bohr's model, Schrodinger's equation. I don't really remember what that is, but I do know that this one is to um, give a give a probability of a position or something for a particle. I think I can't quite remember. This hat is Planck's constant. This is an imaginary number, and this is a differentiation of the wave function that electron or particle is undergoing. Describes probability. Yeah. Oh yeah. Okay. So maybe this is what we were looking at before. I don't really remember doing this, but um, let's see. Um, n equals 2, n equals 1. So I guess this is the shells, and then we're saying that the negative electron are going to move towards. This is exactly what we're doing. Okay, cool. Proton. Yeah. Doing some kind of assessment of that. Okay. Um, as L becomes larger, shape becomes more complex. Oh yeah, that was some kind of definition of a shell. So electron shell is if you have the protons and neutrons in the middle, then the shell is that kind of energy or route that the electrons take. And these shells can look very different, look very strange, um, as the angular momentum increases. Okay, maybe. S equals 0 times mass. S equals 1 dot product, is that? Or 2? 1 or 2. Does need M to define orientation. S I guess stands for shell, but I don't know. I don't know what I was trying to do there. I have to look back at the last video. Let's see. N does not equal 0 because 0 implies it does not exist. N does not equal 0. Okay. M negative L and plus L. Mass times the variation in angular momentum. N, L, M are maybe different types of shells. It's unclear. My notes are terrible. This is trying to talk about an emission of an electron, I suppose. The energy required to do so, just some random drawing. Back to shells. Although there is no pattern in the first four letters, S, P, D, F, the letters progress alphabetically from that point, G, H, and so on. Some of the allowed combinations of the N and L quantum numbers are shown in the figure below. All right. Oh, and that's it. So let me zoom out of that one. Let's go into a new page, episode 18, and we shall start. It's so annoying. I joined this live thing, feeling very energetic in my head, and now it's all gone. I don't know where that's gone. Maybe I need another coffee. Funnily enough, I got one there. Episode 18. So first things first, I guess, is get onto that Duolingo. Greek. Hello, Greek. Yes. Uh-oh. So let's do a warm up then.
Na.
Na. Because the V is the N.
Nana.
Nana. That's... what does it say? Type in English. Nana. Nana. I don't know what that means.
Nana.
Okay, it means Nana.
An.
Anne.
Z.
Z is the... Oh, okay,
C.
this one.
Maria και Mark.
So the P is an R, so it's Maria. K is and the P is an R, so Mark.
Ma.
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 Select the characteristics for Ma. That's the, this one is the M.
Ma. Ma.
Ma.
Ma. Anna και Mark.
Anna and Mark. Select the correct characters for Na.
Να.
Na.
Mark και Maria.
Mark and Maria. Nice. Select the correct characters for Anne.
Αν. Αν από το νερό.
Anna. The water. Nero. I remember
Nero.
from Cafe Nero. Yep.
Ναι.
I didn't hear that.
Ναι.
Nay.
Ναι.
Okay.
Αν από το καρότο.
Anna. The carrot. Is that how you spell carrot? I have no idea.
Carotto.
Yes. Select the correct characters for nay. Nay.
Ναι.
Nay.
Ναι.
Nay.
Μαρία το καρότο.
Maria. The carrot. Bless her.
Νανά το νερό.
Nana. The water.
Νανά το καρότο.
Nana. The carrot. Alright, we did okay. That's some new coffee I got. It's very interesting. It has like a sticky finish. Nice. Forms of S. Match the pairs. Na.
Ma.
Ma. I've already got it wrong. Ma. Me. Where's the M? Me.
Με.
Ria is the P.
Ρία.
Os is the
Os.
Os. Oh no. Oh, yeah. This is sigma, so snow.
Πώς.
What do you hear? Os.
Πώς.
Os.
Πώς.
Os. Os.
Πώς.
Os. Okay. Match the pairs. Me.
Με.
Me. Me. Snow. Snow.
Snow.
This is beta, so it's going to be V.
V.
V. Okay. I forgot that one.
Ρία.
Ria. Os.
Os.
It's like Os. It's got a little C with the tack. The Uzu. So do.
Το.
Uzo. Uzo. Okay. Select the correct characters for snow. Sigma. N.
Σνο.
Sno.
Σνο.
Sno. It's the N.
Σνο. Με.
Me.
Με.
Me. me, me.
Ναι το βίντεο.
Nay is oh shit, what is nay? Is it and? And the video, maybe. Yes, nay is yes, okay. A snack. This will be, this is, oh, is this single? Can't remember now. Snack with ouzo. It has to be that, I didn't know. Maybe, okay, let's have a little look at this. Keyboard. Maybe that is a capital. It might be. Let's see, Greek. Shift. Where's the, that's that. Yes, okay, so sigma. Because I was thinking that must be sigma. Snack
Snack.
with, I guess it's me.
Με.
Ouzo. So with is me.
Αυτός κάνει ούζο.
Ah, this is man, I think. Man. Oh, haha. Man. Kane. I don't know. I can't
Κάνει.
remember. Makes.
Αυτός.
Oh, he. He makes ouzo. I have no idea what ouzo is.
Ούζο.
Let's have a look what ouzo is. Oh, oh yeah, alcohol. I see. He makes ouzo. So
Αυτός.
aftos kane.
Κάνει.
Kani.
Αυτός.
Aftos kani.
Κάνει.
He makes aftos
Αυτός.
gani
Κάνει.
a video.
Βίντεο.
Video.
Ούζο με σνακ.
Ouzo with snack. With a snack.
Βίντεο και σνακ.
Video and snack.
Ναι το βίντεο.
Yes, the video. Okay, I think we've got it now. Cool, okay, so I'll close that down. Let's get rid of this. Let's make sure we're zoomed in. Yeah, so the first things first, I was having a play with the code after I left, I think, the last call, and I'm just trying to make a little foundation on which I can build various tooling. So if I just run this, and I need to get rid of all these errors because I was messing around. I think I changed the name of one of them. Let's see. Model Windows main window. Source code string cannot contain null bytes. Okay. Dashboard widget. UI dashboard. Oh, I know what it is. I need to haha, okay. I need to change the, so my UI file is called dashboard widget and this is now called dashboard, but it needs to be called dashboard widget. So let's run this UI compiler script. So to change to compile the dashboard UI into the Python file. There it is. So now it's called that. And so now this shouldn't complain. Ah, something here. Okay, let me close others. A bit confused here. Where's my main? Not my main window, don't care about that. I want the main, please. Main. Run. Okay, so this is now saying line 6 of this file from dashboard widget import UI. And then main window has a problem. So main window, maybe it's this one actually. Ah yes, I think this is now gone. Dashboard widget, okay. Okay, cool. Let's see if that works now. What have we got now? So it says cannot contain null from UI dashboard widget. And this is on the main window still. So if we go back to my main window, what else have we got here? And the error is source code string cannot contain null bytes, value error on line 6 of the dashboard widget. So it's still happening on that. And it comes from the main window, line 5. This. And if I go through to that, here it is. Well, I don't know what's wrong with that. Let me just try one more time. That's strange. What is it trying to tell me? Models is important from main. Models are app, great. And then app is imported from what was it? It was debug console output. That's annoying. Oh, here we go. What are you telling me? No module found with. I think that's over now. So let me stop this. Let me clear the screen. I'm a bit confused. I don't get those errors here. Okay, that's not very helpful. There must be a way of doing that. Okay. Maybe in this one. Cool stack. Here we go. Oh, that's better. Nice. App.py tries to include the main window. The main window tries to include the dashboard. The dashboard tries to include. What is wrong with this? Let me delete that. Where is it getting this from? Is not defined. So if I go here, add, right, and it's going to go into there. Oh, hang on. Is this stupid thing whereby this is the wrong type of file? Look, UTF. There it is. So let me put a little note about that as well. Helpful notes. Let's go problems and solutions. That is annoying. After using PySide 6 UIC, the UTF format of the file is wrong. It should be UTF-8. It is instead, what is it? It is instead a UTF-16LE. Line endings, let's have a look. README. UTF-16LE. So let's call this that, and then put this as a comment underneath. Alright, okay, that's probably looking pretty sharp now. Can you even see this? Let me see. Can you see this? Not really. Not really. Let me zoom in. How about now? Just the problem with having this wide screen. Yeah, that's a bit better, isn't it? Yeah, you can read that now. Sorry it's a bit grainy. Okay, in fact, you know what I'll do is I'll open it up. So now that's done, let's... Oh no, yeah, I wrote the problem down but I didn't solve it yet. So let me go to the output file. And then save with encoding UTF-8. Now let's try. Okay, different error now, good. UI dashboard widget takes no arguments. Dashboard widget. Dashboard widget. Dashboard widget. Don't need this anymore. Oh, actually though, it's going to be a dashboard button. I'll show you what that means in a second. Dashboard button clicked. Dashboard button clicked. Dashboard widget. create dashboard widget. I think actually this might be pretty useless now. Yeah, I think it is. Yeah, it is. Okay. So actually I need to do this. That widget operation model self.main window this one dashboard widget. Right, sorry about that. It probably doesn't make much sense there. But what's this problem then? So trying to get one of these up and it doesn't take any arguments. That's probably because it needs that instead. Dashboard widget. Dashboard widget. Okay, it's because I made some code for. So I made this code and then used it for another piece of work. Yeah, I've just been doing stuff in the evenings trying to get this to work, and then I used it for something else, and now I'm trying to repurpose it for this now. Okay. And now we need to include this. Yes. Alright, I think we're there now. I guess this doesn't exist. Dashboard button, so let's go to my designer. Dashboard button does exist. But I need to recompile this, so in fact, let me see if I can save some time here. View Python code. Yeah, let's just do that instead. Main window .py. That's going to go there. How's that going now? Oh yeah, great. Okay. So this was what I made. Right. So what I need to do. Let me see how visible this is on the screen. One sec. It's not very visible. But it'll do. Let me just take a sip of coffee. Okay. Wow, it's a lovely aftertaste on that one. So what I'm aiming for is to, I suppose first I'll try and make some input fields. You'll click a button, it'll do some calculation, and it will give you an output. So I don't know what those buttons are going to be yet. So I think we've done enough here, actually. I think we're in a good place. Do I have a Git for this? Because I need to send it up. Yep, that looks good. Okay, modified to rename parts and solve compilation errors. Push. Awesome. So now back onto actually learning stuff. Whew, okay. I think I'm going to take another look for all this stuff maybe. Quantum numbers and electron configurations. The Bohr model, let me resize this, was a one-dimensional model that used one quantum number to describe the distribution of electrons in the atom. The Bohr model was a one-dimensional model that used one quantum number to describe the distribution of electrons in the atom. Let me draw this stuff whilst I'm talking. So, let's see, draw Bohr model is seemingly like you've got your atom or your neutron protons, and you've got your electrons. Let's say this is x as a vector. Whoops. y as a vector. Oh God, I can make this better. And z as a vector. And the Bohr model explains this position of y, z, and x as one variable, and I think it is a wave function. Let me guess that, but let's go back to y. Let's have a look. The Bohr model is a one-dimensional model that used one quantum number to describe the distribution of electrons in the atom. The only information that was important was the size of the orbit. So let's copy that. That's good. I like that. Always yawn on this call, on this thing. That's good. We like that. Let's get that in there. Let me slide along more, please. Thank you. And in fact, let me get rid of my ugly writing here. And we'll put this next to this. Right. Oh man, this is going really well. Okay. So that's that. The only information that was important was the size of the orbit, which was described by the n quantum number. Schrödinger's model allowed the electron to occupy three-dimensional space. It therefore required three coordinates, or three quantum numbers, to describe the orbitals in which electrons can be found. The three coordinates that come from Schrödinger's wave equations are the principal n, angular L, and magnetic m quantum numbers. These quantum numbers describe the size, shape, and orientation. So let me just write this out again. So it's, oh well, let me just make sure I've got a little snippet here. Okay. In fact, I'm just gonna basically have a whole copy of the whole HTML, aren't I? The principal quantum number n describes the size of the orbital. Orbitals for which n equals 2 are larger than those for which n equals 1. Cool. For example, because they have opposite electrical charges, electrons are attracted to the nucleus of the atom due to the protons. Energy must therefore be absorbed to excite an electron from an orbital in which the electron is close to the nucleus, n equals 1, into an orbital in which it is further from the nucleus, n equals 2. The principal quantum number therefore indirectly describes the energy of an orbital. So I think okay, let me just read on. The angular quantum number L describes the shape of the orbital. Orbitals have shapes that are best described as spherical, L equals 0, polar, L equals 1, or cloverleaf, L equals 2. They can even take on more complex shapes as the value of the angular quantum number becomes larger. Okay. So here's something interesting. So these, I guess, are like entities in code for which an entity provides an ID to define which element we're talking about. Or let's talk about set theory, in which you have within the set you have these elements, and those elements have to be defined by a number. Well, not really, no. So it's basically just identifying them, I think. So I suppose what I was trying to get to with the set theory is that each element can then be described, with its actual attributes, but from outside of that set, you don't really care too much. You've just got this, squiggle, and you've got was it L describes the shape order. So you would have L, but underneath that set, uh, L would be, of course, a set of other defining meta information, other meta info kind of thing. So I'm trying to think of this as how I'm going to program this stuff. This would be an object, which I'll assign just one value to at the moment, its ID. But then of course I can expand it, with different properties to include its meta information at a later date when that's required, if it is ever required. There is only one way in which a sphere L equals 0 can be oriented in space. There is only one way in which a sphere can be oriented in space. That makes sense. Orbitals that have polar L equals 1 or cloverleaf L equals 2 shapes, however, can point in different directions. Orbitals that have polar or cloverleaf can point in different directions. That makes complete sense. To describe the orientation in space of a particular orbital. Oh, I see. We therefore need a third quantum number known as the magnetic quantum number m. Magnetic quantum number. To describe the orientation in space of a particular orbital. It is called the magnetic. I was literally just about to ask that. Because the effect of different orientations of orbitals was first absorbed in the presence of a magnetic field. I see. So I think with that being said, let's give ourselves some fields here. M, L, N. I think that's it, right? Yeah. N, L, and M. Let's do that. Let's go and program that in. So we've got something to work with. So so here's my side navigation so I can have more options, and here's my main main screen. This is like a title, and this is the widget that gets filled up in here. So in my dashboard widget, well, actually, in my page 2 button, page 2 widget, yeah, this is not well done. What have I got here? Bear with me. Page 1, and I've got a page 2. What is that? So that's not going to be anything, right? But I have made widgets. So okay, so let's call this one. Okay, jeez. Let's just delete page 2 for now. Page 1 will become let's see. Page 1 will become what is this page called? Quantum numbers. Let's call this quantum numbers is too confusing. I won't remember what that is the next day. Description of electrons. Let's call it electrons. Okay, let's call it electrons. So electron widget. Save. Does that? Yeah, great. Okay. And inside here, we're going to call this electrons widget, I guess. Let's call this electrons. Let's just put a space in there. Whoops. And then inside here, we're going to have input fields. So input. Oh, was it line edit? That's the one. Oh, and we need this to be vertical layout. Vertical layout. Line edit. Line edit. Line edit. Beautiful. And then we're going to have some labels to this. Can I do a label? Yeah. Label 1, label 2, label 3. Yksi, kaksi, kolme in Finnish. 1, 2, 3. Let's go. So this one will be the n, which is the size of orbit. This will be ml, the shape of orbit, and this will be m, magnetic. I don't like that term, it's just so confusing, which is whatever it was. Sorry you can't see much of this. This is I don't know if I can zoom in at all. Let me see. Maybe I can. It'll be even good for me because it's a bit small for me. Preview zoom. How about that? Nope. Percent. There must be a way of doing this. Tool window font. Point size 16. No. Aye aye aye. What was 9 before? Let me just double check this. How to make font bigger in Qt Designer. Select Fonts and Colors tab under the font heading after where it says Family. Oh, apparently there's an options. I don't think I have that. Maybe I do. Form settings? Nope. View? Toolbars? Configure toolbars? No. Preferences? It seems pretty stripped down. Oh, that's frustrating. I really want to be able to show you guys. You can't see anything though. It's just like a big smudge. Shame. Okay, fine. So let's go magnetic. What was it again? The angular quantum number. Oh yeah, and let's give them their proper name as well. N, size of orbit. So N. That is size of orbit. We got angular quantum number. Shape of orbit. Then we've got what? Magnetic quantum number. And the orientation in space of a particular orbit. So orientation of orbit. Okay. Orientation of orbit. Cool. Let's go and form that up. Oh, you know what? I need to go to the toilet. This is so annoying. Let me just. Yeah, let me just stop the stream and I'll be back as soon as possible. Okay. So sorry about that.